Hello. I want to start out with just going over a couple of things that we talked about in the last class session when we started dealing with the four ways to write the equation of a line. So if you remember right here, if we're given the slope and we're given a point that is actually on the line, remember this is actually what we call a good point. So we would say we would represent this with a x, represent that with a y, and we plug it into the slope intercept form equation. So remember that's y equals mx plus b. Well, this means that we'll replace the y with -1. We'll replace the x with the m with 2/3. We'll replace the x with -9, and we'll just keep the b. So when we simplify a fraction times an integer, remember we can do it one or two ways. We can either divide -9 by 1, or we can just say 2 times -9 gives us -18 divided by 3, which is -6. So that means we get -1 is equal to -6 plus b. Add 6 to both sides, and you end up with a 5 is equal to b. So when we get our final answer will actually come out to be y equals 2/3 x plus 5, because we just replaced the y, we replaced the x, the slope with 2/3, and we replaced the actual slope y-intercept with 5. Over here, the question is, well, how do we find the equation of a line if we're given 2 points? Once again, these are what we call two good points. And the hint to this right here is, remember, if my x values are the same, that means that I have a vertical line. All right, since these two things right here are the same, that means that I have a vertical line. And whenever I have a vertical line, that means that even if I write y equals mx plus b, that actually means that a vertical line has what we call an undefined slope. And when we say an undefined slope, that means that we have the same x values, which means that we're going to actually have x equals, and whatever the x value is, which in this case is 2. All right? And so we get x equals -2. Excuse me. The next thing, we're given 2 points. Once again, these are 2 good points. And what we're saying right here is that now, unlike number 2, these 2 x coordinates are not the same. So I will go through and I will actually solve this. First of all, I'm going to find the slope. Well, remember, we have to label x1, y1, x2, y2. And we just plug it into the slope formula. We get 8 minus 6 over 2 minus -2. That'll give us a 2 over 4, which comes out to be 1/2. And then we can actually take one of these points, and I always say take the first one, plug it in 2, and you end up getting, plug it into here, and you end up getting a 6 equals 1/2 times -2 plus b. And we see that our b actually comes out to equal, your b will come out to equal a +7. And so when we take this and plug it in, we end up getting y equals 1/2 x plus 7. Over here, since our slope is 0, remember whenever your slope is 0, that means that you have a horizontal line. And horizontal line means that all of your y values are the same. All right, so this means we have a horizontal line, which means that all of our y values are the same. Y values equal. I would say same or equal. And so therefore we know that we end up with a y equals 4. Here we have 2 graphs. Remember, when we say graphs, we're talking about good points. So if we're dealing with good points, that's one good point. This is another good point. We actually have other good points on here. We could say this is a good point. 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 So remember, there's more than just two good points. So either two of those 5 points we could use. And so remember, once we decide that we're going to use good points, well, then the next thing that we do is we say, well, let's label our points first, get the coordinates. So that means we end up with a +1, -1, and we end up with a 0, -3. And so now basically what we're doing is we need to figure out what is the equation of the line. Now, one thing you could do, since we're dealing with good points, you could just use the counting method to find the slope. Remember, rise over run. Because remember, another way to remember slope is just rise over run. So one thing that I could say is, okay, starting from here, from this point, I went up 1, 2 slots, and I ran to the right 1 slot, and so therefore my slope would actually be 2. Now, since our line crosses the y-axis at this coordinate, whenever your x-coordinate is 0, the y-coordinate also represents the y-intercept. And so therefore we know that our b is equal to -3. And so when we plug that into the slope-intercept form equation, we end up getting y equals 2x minus 3. Same process right here. We find 2 good points. That's 1 good point. That's another good point. This is a good point. That's a good point. This is a good point. But we're just going to use those 2. So if we go through the same process, labeling our points first, right? Now what you can do is if you want to use that same method that we just did to find the slope, well, depending on which one of these points you want to say is your first and which one is your second, it really doesn't matter. You're still going to get the same thing. Well, now starting here, we went down 1, 2, 3. So that would be a -3 as our rise. And we went to the right 1, 2, and that would be a +2 as our run. And then in order to find the slope, the y-intercept, well, it crosses right here. But if we labeled this, this would be 0, 3. Just like this right here would be 2, 0. And remember, since our x-coordinate is 0, the y-coordinate represents the y-intercept. And so therefore, we end up with y equals -2/3 x plus 3. Here's an EOCT practice question for you. Remember right here, since our our angle is what we call a inscribed angle, because the vertex is actually on the circle. Remember, for an inscribed angle, all right, and I would say inscribed angle, the arc is the arc is twice the size of the angle. All right, so it's 2 times the arc. Or we could say the arc is, we could say that in order to find the inscribed angle, let me erase that. I'm getting myself mixed up. I'm human, I make mistakes. So if we're trying to find the angle, all right, if we're trying to find this angle right here, then we take the arc and we divide it by 2. But if I'm trying to find the arc, then I take the angle and multiply it by 2. And since they're telling us right here that arc QR, which is right here, is 72 degrees, well, that means that I can actually take it and plug it into here, all right? I can take it and plug it into here and find the angle, or I can take it up here and find the angle. Doesn't matter which way you decide to do it, but just remember, the arc is twice the size of the angle. So therefore, if this arc is 72 degrees, that means that this angle has to be half of that. So we would use this one. And we end up getting 36. And so C would be our answer. So when we're talking about parallel lines, because that's what we're getting into today, parallel and perpendicular lines. One thing about parallel lines that you need to remember is that parallel lines never intersect and are in the same plane. Right? They never intersect and they're in the same plane. When you're dealing with equations for parallel lines, 2 things you need to make sure you remember. Parallel lines have the same slopes but they have different y-intercepts. So remember, just to reiterate, when we're dealing with slopes, remember the slope is represented by the m and the y-intercept is represented by the b. Okay? So an example would be for parallel lines, we could say y equals 2x plus 5, y equals 2x minus 8. Notice, same slopes, different y-intercepts. So how do we write an equation of a line and we're saying that these two things are parallel to one another, right? So the first thing we need to make sure we understand is, given the equation, we should be solved for y. Basically what we're saying is that if I give you an equation and the y is not isolated, I have to isolate it, or it is best that I isolate the y variable first. Write down the slope of that line. So once you put it into slope-intercept form, you're going to write down the slope of that line. Then you're going to substitute m and x comma y into your equation to find the y-intercept. And then you're going to write the equation using m and b. All right. So one thing I want to make sure we do, just to make sure we understand what I mean when I say in number one, solve for y. So if I gave you the equation 2x plus 3y equals 9. Well, if we notice, this is not solved for y, meaning the y is not isolated. So remember, there's a couple of steps that we need to do. Well, first of all, we're going to take the 2x and move it over here. So that means we get 3y is equal to, well, remember, anytime you bring something across the equal sign, then it changes signs. So now this positive 2x becomes a negative 2x. And since this 9 stayed over here, it just stays a plus 9. But once again, I have to not only get the y by itself in this case, but I also have to isolate it. So therefore, this y still has a 3 with it. And so therefore, I divide everything by 3. And so now I end up with y equals negative 2/3 x plus 3. And that's simply because I divided everything by the number in front of the y. So that's an example of what we mean right there. So let's look at this first one right here. It says, write a line parallel to the line 2x plus y equals 3 and passes through the point 2 comma negative 5. All right, 2 comma negative 5. And this is number 3 in your handout. All right, this is number 3 in your handout. So the first thing that we need to do right here, let's look at what the directions tell us. All right, first of all, is our equation solved for y? No, it's not. So the first thing we would do is we would actually solve this thing for y. So I would take this 2x plus y equals 3. Remember what the steps I just told you. We were going to take the y. We're going to move everything over here. And remember, when we cross the equal sign, it changes signs. And we're going to just say plus 3. If this was a negative 3, then it would just say minus 3. Right here, now we have our y is isolated because the only number in front of it is an understood 1. And so now the next thing says, well, given this equation and the point that it passes through, can I write another equation that's parallel to it? Another equation of a line that's parallel to it. So therefore, let's look at what we do. The steps say, write down the slope, all right, of that line. Substitute the m and xy in for y equals mx plus b. All right. So therefore, what we're saying right here is that if I'm going to do that, I'm going to get, and I'll write down y equals mx plus b. I'm going to take the slope that I found, because remember these slopes are the same, all right, and the slope is -2. So I'm going to replace the m with -2. I'm going to replace, remember this is an x and this is a y, I'm going to replace the y with 5 of my point. I'm going to replace the x with a -2. And I'm just going to solve for b. Solving for b means that I end up getting a 4 plus b, and then when I subtract 4, I end up getting a 1. So my b is equal to 1. So now what I'm saying is this. In order for my two lines to be parallel, they have to have the same slope, but their y-intercepts have to be different. Well, looking at what my first equation says, my first equation is y equals -2x plus 3. If I write the equation for my second line, y equals, well, what's the slope of my second line? It's the same as the first because they're parallel. And the y-intercept came out to be +1. And so therefore we see what our answer is. Let's look at the second one. The second one, same thing. We want to write a line that's parallel. So therefore, write the equation of a line, that's parallel. So let's follow the steps. The steps say, first, is my equation is my equation in slope-intercept form? Yes, it is. It's y equals 3x minus 5. And so therefore, I don't have anything to do to this first equation. It's already simplified for me. My slope is equal to 3. And so now what I need to do is take the y equals mx plus b. Remember, this is x and this is y. Plug in what I'm given. Well, my y is -2. My slope is 3. My x is -5. And I'm solving for my b. That gives me -2x. This gives me -15 plus b. When I add 15 to both sides, I get 13 is equal to b. So therefore, my first equation is y equals 3x minus 5. My second equation is y equals, well, my slope is still 3. And now my y-intercept comes out to be positive 13. I want you to pause the video and try to do this one. And your answer should come out to be -4x plus 7. Same thing for this one, number 6 on your handout. Remember, follow the steps. Is my equation in slope-intercept form, meaning is the y isolated? Secondly, what's the slope? Third thing, what's the equation of my new parallel line? And then fourth one, are the two parallel? Go through this problem and your answer should come out to be y equals -x minus 8. Now let's think about perpendicular lines. So when we're dealing with perpendicular lines, the first thing we need to remember is that perpendicular lines intersect at 90-degree angles, meaning they make right angles. Right? When we're dealing with the equations of perpendicular lines, remember, equations of perpendicular lines, the slopes of those lines are opposite reciprocals of one another with the same or different y-intercepts though. So basically, the difference between perpendicular and parallel lines, slopes are the same. Perpendicular lines, slopes are different, but they're different in a specific way. Not only are they different numbers, but they're different signs. Right? They're different numbers and different signs. So examples of this would be, when we say opposite reciprocals, 2 And the opposite reciprocal of that would be negative, because remember, opposite means different signs, and the reciprocal of 2 is 1 over 2. Or if I said negative 3, opposite means the positive, it becomes a positive, and the reciprocal means that it becomes 1 over 3. Or even if I had a fraction, if my fraction came out to be negative 2/3, the opposite says that now my new slope is positive, but the reciprocal says that I take this fraction and flip it. So that's what we mean when we say opposite reciprocals. With this with the y-intercept though, remember the y-intercept can be the same number or it can be a different number. So let's look at these problems. These are just some example reciprocal problems, right? Well, remember the opposite reciprocal for the first one is positive 3 over 2. The second one, negative 12 over 11. The third one thing that a lot of students like to do is they like to convert it into a fraction. But even if you do convert it into a fraction first, and one thing that I tell students when you're dealing with slopes, make it a fraction if possible. But if not, it won't hurt you. But regardless, it becomes negative 1 over 7. And then right here for the fourth one, remember opposite reciprocal says that it becomes positive 9. And if you look at this, also you can look at it as being positive 9 over 1, if you want to look at it that way. So let's look at the examples that we're given right here. All right. It says, are these lines perpendicular, parallel, perpendicular, or neither? Well, remember, in order for them to be parallel, slopes have to be the same. Y-intercepts have to be different. In order for them to be perpendicular, slopes have to be what we call opposite reciprocals of one another. So when we're dealing with the slopes, the signs have to be different, meaning one has to be positive and one has to be negative. And then they have to also be reciprocals of one another. So when you look at this first one, notice that the first thing you do after you put them in slope-intercept form is you look at your slopes. Well, when I look at these slopes right here, what do those slopes tell me? Well, those slopes tell me that they're the same number, sign and all, so therefore they must be parallel. Also, we need to look at that these y-intercepts are different. Well, what about the second one right here? When I look at these slopes are not the same, so they can't be parallel. Sure, they have different signs, but they're not reciprocals of one another. All right. And since these slopes are not reciprocals, even though they have opposite signs, they're not reciprocals. That means that they must be neither. We could care less about the y-intercept if the slope doesn't fit parallel or perpendicular. Well, what about right here? Let's look at it. Look at my slopes. Well, I've got a positive and a negative, so possibly it could work. 1/5 is the reciprocal of 5. Boom, that works. All right. And then even when we look at the y-intercept, remember, if the slopes are opposite reciprocals, your y-intercept can be the same or different. So therefore, they must be perpendicular. Let's look at these problems right here. These are just example problems. Once again, when I look at them, I look at my slopes. The slopes have the same sign, but they're not the same number. So therefore, must be neither. Even though they're reciprocals of one another, remember, in order for it to be perpendicular, they have to be opposite reciprocals, meaning signs have to be different and they must be reciprocals also. When I look right here, this is one that'll throw students off simply because they don't see that the slopes are out of place right here. Well, that's the reason why we say put it in slope-intercept form. When you put it in slope-intercept form, that means that you're always going to put your x term first, which in this case, all I'm doing is taking the 3x and putting it right here. Notice it's not crossing the equal sign. It's just changing positions with your 1. And so therefore we end up with this. Now it's a little bit easier to see, and now we can see that our slopes are the same or congruent, and so therefore it must be parallel. When we look right here, we look at our slopes. Notice what we're saying about the slopes. We're saying that, okay, they are opposites of one another. Oh, sorry. All right, they're opposites of one another. Sorry. All right, so our slopes are opposites of one another. And they are reciprocals of one another, so therefore that makes them perpendicular. So how do we write an equation of a line that's perpendicular to another and a given point? So this is starting number 7. So when we look at it, the first thing we need to do once again is we need to make sure that it's in slope-intercept form. Second thing, write down the opposite reciprocal of the slope of the line that you found. Third thing, substitute m and xy in y equals mx plus b. Fourth thing, we're going to solve for b. Fifth thing, we're going to write down the equation using m and b. So let's look at the example. So it says write a line perpendicular to the line y equals 1/2 x minus 2 and passes through the point 1, 0. Well, let's think about what we're saying right here. Well, first of all, remember, in order for my lines to be perpendicular, the slopes have to be opposite reciprocals first, and their y-intercepts have to be different. So the directions tell us, first of all, is it in slope-intercept form, meaning is my y isolated? Yes, my y is isolated. Second thing, since my y is isolated and it's in slope-intercept form, then what is the slope? Well, the slope is 1/2. But since we want perpendicular slope, the perpendicular slope, right, now says that we do the opposite reciprocal of this, which is -2/1. Because remember, if my slope is 1/2, then a perpendicular slope is -2/1. I take this and I plug it into my y equals mx plus b equation. And remember, this is my x and this is my y. So I'm going to replace this y with 0. I'll replace this m with this new m, which is -2/1, or I could have just said -2, because remember it means the same thing. My x is 1, and now I'm just solving for b. Well, this gives me 0 is equal to -2 plus b. Adding 2 to both sides, remember this is adding 2. This becomes my b is equal to 2. So let's look at it. So for my original equation, y equals 1/2 x minus 2. For my new perpendicular equation, y equals -2, because that was my slope, x plus 2. Well, does it satisfy perpendicular? Yes, it does. And so therefore, we see what our answer comes out to be. Let's look at the next one. Write a line perpendicular to the line y equals -3x plus 2 and passes through the point 6, 5. So when we look at it, well, we know this is our x and this is our y. Is our equation in slope-intercept form? Yes, it is. The y is isolated. Next thing, what is the slope? Well, my slope of this equation is -3. But since I want a perpendicular slope, then that means that I have to basically take the -3 and do the opposite reciprocal. Well, remember, reciprocal means that it becomes a 1/3, and opposite means that the sign changes. So now I take it and I take this y, this slope, which is the perpendicular slope, this x, and I plug it in. That gives me 5 equals 2 plus b, which means that I get positive 3, I'm sorry, because we're subtracting 2 from both sides. We get positive 3 is equal to b. So therefore, my original equation was negative 3x plus 2. My new equation says that the slope is 1/3 x, and my y-intercept is a positive 3. And so therefore, we see what we get. Let's look at this equation, or this problem. We still want to do perpendicular, and it says write a line perpendicular to the line 2x plus 3y equals 9 and passes through the point 6, negative 1. Well, let's look at it. First of all, is my equation 2x plus 3y equals 9, is this equation in slope-intercept form? Meaning, is my y isolated? No, it is not. Look at all this on this left side. So therefore, the way that we solve it is we're going to bring down our y term, 3y, equals, remember, we take the 2x and move it over here. Once we cross it over the equal sign, it becomes a negative 2x, and we have a plus 9. The next step is to take it and divide it by 3, because that's the number in front of the y, and we end up with y equals negative 2/3 x plus 3. So now we have it in slope-intercept form. Well, now we can go through and solve like we did the previous problems. Well, if we notice that our slope is equal to negative 2/3, but since we want a perpendicular slope, well, that means that I have to take the reciprocal and change the sign. So the reciprocal of that is positive 3/2. Using the same process, y equals mx plus b. Remember, this is my x and this is my y. This becomes negative 1 is equal to, well, my new slope is 3/2. My x is 6. This right here becomes a negative 1 is equal to 9. So my b comes out to be negative 10. All right, my b comes out to be negative 10. Well, my original equation we found to be y equals negative 2/3 x plus 3. Remember, in order for this to be perpendicular, my new slope has to be opposite reciprocal and my y-intercept has to be different. And so when we plug it in, you end up getting y equals 3/2, because remember, that's what we found our slope to be, and x minus 10, because that's what we found our new y-intercept to be. Looking at number 10 right here, what are we saying? Well, we're going through the same process. Is it in slope-intercept form? Yes, it is. Right? Pause the video and see if you can come out with the correct answer, which is negative 1/2 x plus 5. So I hope this video has been informative for you. Please make sure that you use the handouts that goes along with this video. And I look forward with working you the next time. Thank you.